Okay, guys, we are starting our new module. We've been talking about weathering and erosion and what that creates, which is sediment, which eventually becomes our soil. So our question for this module is, what is the composition of soil? Remember, composition is what something is made of. So when we're saying what's the composition of soil, we're talking about what it's made of. So this goes along with standard S6E5H, which says describe soil as consisting of weathered rocks and decomposed organic material. And as you are working through this module, you are going to be filling in these notes that you should have gotten from the front counter. And I will try and stop and say, write this down, but you can see there's some labeling, more labeling, there's some fill in the blank, and then at the bottom, you will be labeling there as well. So what is the composition of soil? Well, it has air in it. We don't always think the soil has air in it, but we want soil to have air in it. That allows it to breathe, and it allows it to become better soil as decomposing takes place. It has water, sometimes not enough, sometimes too much, but soil has water in it. Then it has the soil particles, which is what you probably were thinking of to start with. Soil particles that consist of rock that's been weathered, mineral particles, which are also weathered rock. And those mineral particles consist of things like clay, sand, and silt. And silt is a very, very, very fine weathered type of rock. And then it has decomposed organic matter. Here's that organic word again. I said that we're going to hear about this all year. So organic, remember, means something that is alive or was once alive. So decomposed means probably not alive anymore because it's decomposing. That means it's breaking down and kind of rotting, what you would say of as rotting. So what is the composition of soil when we look at it on a pie graph? Well, minerals are almost half, 45% of soil is made up of minerals, and then we have 25%, which is 1/4, is air, 25% water, and then that last 5% would be the organic materials. So that would be 5%. I can see that's a little bit cut off, but that's 5%. So you should have, on the slide before this, you should have written the composition of soil, what it's made of, and then label this diagram here with the percentages. Pause, remember, if you need to do that. Okay. Soil has many small spaces between the individual soil particles that are filled with water or air. Like I said earlier, we think that the soil is really, really tightly packed in there, but usually it's not. It has lots of pockets, sometimes filled with water, sometimes air. If it's dry soil, then it's going to be more air. If it's a very wet soil, it's going to be more water. If you've ever come upon clay soil, then it doesn't have as much water or air in it, especially not as much air. It's got a lot of closed-in space and not a lot of air pockets. So you see, you have 50% of soil is particles in the organic matter, and then 25% the air and 25% the water, which is the same thing as that pie graph, just looking at it differently now. So this is a comparison of wet soil and dry soil. So you can see soil particles are the same size in both pictures, but this is a wet soil. So you see more water here, a little bit of air. This is a dry soil that needs water. Lots more air than water. So this is a drier soil. So on your diagram, we want to label what all these things are. The obviously brown spots are the soil particles. The white spots, which yours is not white, I understand that, is the air pockets, and then the other space is water. And feel free to color that to help you. I know some of you won't though, but you can. Okay, the rocks and mineral fragments come from rocks. We've been talking about that. We went from minerals to the rock cycle to how they break down. So where does all that come from? It comes from rocks that have been weathered. Most of the fragments are small particles, like I said earlier, of sediment that's clay, sand, or silt. And you should have just written that down. If not, pause and go back. Now, here's a size comparison. This gigantic boulder-looking thing is actually a piece of gravel. But when we look at the measurement here, 2 millimeters, not even 1/16, a little over 1/16 of an inch, so not even an inch big. So this is pretty small. The millimeter is those little bitty tiny notches on the centimeter side of the ruler. So pretty tiny. Sand, even though it looks big, we know that a particle of sand is not very big at all. Silt, tiny, like I said earlier, very tiny compared to a grain of sand and a piece of gravel. And then we have clay, which you can't even see at this scale. It's not big enough to even fit on this scale. So very tiny pieces, gravel being the largest. So earlier I said organic matter is the remains of once living organisms, things that were once alive. That's everywhere in the soil. Things that live in the soil, that die on top of it, plants, when they die, leaves that fall off of trees, all of that is organic matter. Leaves, stems, roots, animals, microorganisms, things that are so small you can't see, those are all the organic matter in the soil. Here's an example. You might look at that and go, oh, I didn't know that was organic matter. Yes, you can see that's pieces of wood, that's stems, that's roots. And the darker it is, the more organic matter there is in the soil. So see how dark that is? That's good. So after that organic matter gets into the soil, it doesn't just sit there. Fungi and bacteria start breaking it down and cause it to decompose. It doesn't do that by itself. It needs some help. And so that's the role of the bacteria and the fungi that's in the soil. Then, after it decays and rots, it turns into humus, which is what plants need as a nutrient. And that's not the same thing as hummus. Hummus is something you eat. This is humus. The difference is humus has one M, whereas hummus has two M's. So this is humus, and that's basically what we call the organic material after it has decayed. So this just shows you that process. We have a tree here with roots. The roots need the minerals in the soil, so they absorb it, but then it's kind of a cycle in itself. The leaves fall off, and we call that leaf litter, because it's where the tree litters on the forest, so it's leaf litter. And then that's organic material, and that starts decomposing with the help of the bacteria. That becomes the humus, and that makes for more minerals and more nutrients for the tree. So the tree makes kind of its own nutrients. This says decomposition creates soil that contains the nutrients that plants need in a form that they use to carry out their life processes, okay? They just can't have any nutrient, like here. Looks like Mr. Worm or centipede, or he's a worm, is offering the tree a piece of pizza. And he says, none for me, thank you, but I would like to have a nice big bowl of manganese, zinc, cobalt, boron, chlorine, and molybdenum. He doesn't like pizza. He needs nutrients specifically for him, and that's not a piece of pizza. So as those worms and insects and animals, as they live in the soil, they dig around and burrow and crawl through. What they're actually doing is they're mixing the humus with the soil, the particles of rock that's in there. So they kind of are the stirrers of all those nutrients, and they move it around, which is a good thing. So when we look at soil, it's not just all the same. It has what we call layers or horizons. That's just another name for layers. So you either can say soil layers or the soil horizons. And this is a good soil profile right here. A profile is just kind of a picture of what it all looks like. So you can see letters here, and so I'm going to talk about what each of those stands for and why these look different. So let's start off with, this is called horizon O, and that's easy to remember because that's the organic matter. Go back. Reverse. Okay, the organic matter is basically all the stuff that's living, where the plants are growing, where the leaf litter is, where twigs are. Basically, when you walk through a forest and you're kicking your feet, all that stuff that you're stirring up is the organic matter. And then some of that actually, the animals that live within the soil in that top little section of the soil, that would be the O horizon as well. So the O horizon's on the very top because it's where the roots are and the leaves and the trees and the bushes and all those things are. Now, so then below the organic horizon O, we have horizon A. And you can remember these as A, B, and C after the O horizon. And horizon A is topsoil. You need topsoil to make plants grow. If you have soil that doesn't have topsoil, then sometimes you have to go and buy some. I know when we plant at home, a lot of years we'll have to go and buy bags of topsoil so that we can add nutrient-rich soil back to what we already have. Because without the topsoil, then plants can't grow. So it's called topsoil. It contains humus, and it doesn't have a lot of large chunks of rocks if it's good topsoil. So it's going to be very fine-grained and have lots of minerals in it. Next, we have horizon B. And horizon B is a lot bigger here. Horizon B is called the subsoil. And if you know stems, you know that sub means under, so it's under the top. Okay, topsoil, subsoil. In horizon B, you're not going to have near as much organic matter. That's why it's lighter in color here and not near as dark. Remember I said the darker it is, the more fertile it is, the more organic material that's in it. You're not going to have a lot of organisms that live down here. You have some tree roots here, but you're not going to have things that burrow down. They usually stay within the topsoil, that horizon A. You're going to have larger chunks of rock, not quite as big as you can see horizon C below it, but you are going to have some rock particles here. You will sometimes have what's called leaching, which is where, like when it rains, the water, as it soaks into the soil, will bring some of the humus down into horizon B, the subsoil, and give it a little bit of fertile texture, but it's not going to give much. I think that's what this picture is showing here. That's not as much tree roots as it is leaching and those nutrients being carried down to horizon B, your subsoil. It's not very fertile. Like I said, if you don't have this and you just have soil that has horizon B, you're not going to be able to grow as much. That's why sometimes people have to add horizon A. They even go as far as adding humus. You can go to the store, go to Walmart, a hardware store, garden store, and you can buy bags of humus as well to add to make that horizon A more fertile. Below that, we have what's called horizon C, the parent rock. Parent, think about your parents. They gave birth to you. So these are the rocks that give birth to the smaller soil here. That eventually these will weather down and they will become smaller and smaller and smaller until they make their way from subsoil to horizon A, the topsoil. So they're called parent rocks. So that's horizon C. Remember, it just goes A, B, C. And you remember top, sub, and then parent rock. Definitely not going to have anything living this deep, not going to grow anything. If you just have horizon C and you don't have any of the stuff above it, you're not going to see much plant growth at all, or trees or anything else. This is what I just talked about. It's the weathered parent rock, consists of partially weathered rock that does give rise to the soil right above it. So it will eventually become this, but it's not there yet. Then we have what's horizon R, and horizon R is bedrock. Bedrock is simply a solid layer of rock that's below the soil horizons. It is not weathered at all. It is just solid rock. If you've ever tried to dig in your yard and reached a solid layer of rock, you did reach the bedrock. You probably didn't have a lot of horizon A, B, or C above it, and that's why it was so easy to reach it. The bedrock is usually pretty deep, but it just depends on the area and what kind of soil profile is above it. Bedrock is where our groundwater is stored. It's nice and clean down here because it's just solid rock. So when we talk about groundwater, It's usually found in the bedrock. So that's the bottom layer. It's not really even the soil, but it's